Hello everyone, welcome back to another one of our Benson Valley Railways. This is another video progressing on my turntable that I'm trying to do with the CMRI, and I'm going to be showing a problem that I posted on the JMRI website, which I've managed to get some sort of workaround, which I'll show you, but it's not the best way of doing it. But anyway, I'll show you the problem and then I'll go through the code and then I'll go through the way I've managed to get it to work. So just what's on the screen at the moment, this is a turntable, similar to what you saw when I was doing the light one. The only difference here is, I mean, you've got multiple outputs on here because I've built up a bit more, but I'm only showing positions 1 and positions 2, and I've got two sensors, S1 and S2 set up. And the way I'm doing this now, I'll just bring up the tables, is I'm setting these up under turnouts now. So I've got two turnouts set out. Turnout on address 8 and address 9 now, and these turnouts are being controlled through the root system. So I'll go through this. There's the turnouts. These are my sensors when it catches up. If it catches up, there you go. There's my sensors, which have got internal addresses, which are the two sensors here on the screen, and then I've set up two roots. So we go to roots and I'll edit to show you the roots. So in the roots, for the root 1, I'm saying that I'm using both the turnouts, and I'm setting the turnout number 1 to throw and turnout number 2 to close, and then got two sensors to show that we're on set active for turnout sensor 1 and set inactive for sensor 2, and this root will be controlled by sensor number 1 when it's active. So if I click on this sensor here, it will basically throw the turnout number 1, which JMRI code will pick up. I'll show you that. Arduino code will pick up and put a pulse. Well, do an if statement to control the stepper motor, which I'll show you in a minute. And so root number 2 is exactly the same. The only difference is we're putting closed on the turnout number 1 and throw on turnout number 2, and the opposite way round on the sensors active, and it's being controlled by number 2 being active. So that's the tables, and the Arduino code is basic stuff at the top we've done before, reading both the sensor inputs, and we're saying that if position 1, which would be the turnout number 1, becomes 1, so that means we're trying to get to position 1. We do the current location, same as what I did on the lights. Couple serial monitors, we do a calculation to say how many steps we're going to move, send that to the stepper motor, and then set the location to number 1, so we don't go through this again. It only goes through this once. And then the same for number 2. So it's quite basically the same as the light code. The only difference is we're using turnouts now, and we're using a root system. And the reason for using a root system is that when I click on this sensor, as I'll show you in a minute, that sensor light goes out, so we can click around all of them and it controls turning off all the other ones at the same time, so it works much better. And in the future, I'm not too sure because I've never done roots before and I've not got into automatic systems before, but it might be a better way of doing it for controlling an automatic system because it's a root. Anyway, so I'll show you it working so I can show you the problem. So if I go to number 2, position number 2, hopefully you see down here the train has just moved to position number 2. So when I click on position number 1, it should go back to the same position, but you'll see it hunt between the two. I'll just get rid of that and show you the code over here. So that was going to location number 2. See all print on the Arduino monitor up here. And down here is the output from the CMRI monitor on the JMRI. Now I'm not clued up on this. I thought I understood it, but now I'm getting a bit more confused. Anyway, I'll clear this and then I'll show you this one going back to number 1. Now if I put number 1, watch what happens to this turnout here and the monitors after it's turned, and you'll see the problem. So you can see it's decided to go to 1, then back to 2, then back to 1 again. And you can see up here the Arduino is actually getting an input from JMRI saying go to number 1, then it's saying go to number 2, then it's saying go back to number 1. And I've tried everything through JMRI and I've not been able to figure out why it's doing this. My theory is that it's putting a 1-bit output on number 1 before it's taking the 1-bit output from 2, so it's the Arduino's getting a signal of duplicated outputs. So this is the monitor output down the bottom, which, like I say, I'm not clued up, so I'll just put it on the screen to show you what's happening. Right, so now my workaround. The only best way I can do this is on here. If I get this position in here, copy that, put that in there, and say change that to number 2, and say that. So we're going to say positioning 1 is equal to 1, and positioning 2 is equal to 0. So we need to make sure that's at 0 before we do anything. And I'll do exactly the same then for the other one. This will be positioning 1 is equal to 0. So I'll upload this part of the code. Or before I upload it, I'll just make sure that it's in the right position. So I'll upload this. Right, so I've uploaded this part of the code, which has got this extra bit in to say that it's got to be equal to 0 before it goes through any of the steps. And I'll clear the monitors, and I'll show you it now working with that bit of code. So that's position 2, and I'll clear this just to show you it working. And back to position 1. So it seems to work now. So that's a workaround, which works quite well. And so now what I do is I'll upload a new bit of code showing you the 8 steps that I've got set up on here. Right, so I'll now go over the Arduino code for doing this in 8 positions quickly. I'm not going to go over this too much in thorough detail, and I won't be putting it on my website for a while because I'm trying to sort out the problems. But you can see here we've got positioning my array of 8 now, so we've got 8 positions, and all the locations are set up here from 1 to 8, giving it each location how many steps I'm going to move from 0 being 0 the reference from where it will start, and then I'm reading the bits coming in from JMRI, and then each position, each if statement is exactly the same, just slightly different on the top part of the if. And this is showing you also why this becomes just more messy really on the if statement. So if position 1 is equal to 1, because that's what we want to move to, and position 2 is equal to 0, position 3 is equal to 0, position 4 is equal to 0, and so on all the way down to 8, and the current location is also not equal to 1, so we're not at 1, then we'll go through this part of the code like we did earlier on, and it works for getting it into that position. There is probably a better way of doing this. I've tried quite a few ways, but I haven't been able to solve a nicer way of doing it. And this goes for the 8 steps all the way down. So that's the Arduino code, basic part of the Arduino code. I'll get rid of that. I've got the serial monitor up here, just clear that. We've got the 8 sensors now all around our turnout. So I've got 8 internal sensors on the JMRI. Tables. There you go, there's my 8 internal sensors. This one is clock running, keeps coming up, and I still don't understand that one yet, so if someone knows about that one, let us know. I'll delete it and it comes back up every time, so it must be something to do with maybe the roots. I have 8 turnouts as well. Another thing that's not going to change over. There you go, 8 turnouts down here for the turntable. They're the top ones are for my actual turnouts on the system. And now I have 8 roots. All the roots are the same as what I just showed you earlier on. Each root, as it turns on, turns all the other roots off and turns all the other turnouts off to closed, and only one would be active in the throw position will be the one that's active. So that's the basic setup. I haven't got the monitor up here for the JMRI monitor. Maybe I need to put that up in case someone wants to see what's going on. CMRI monitor, I should say. So there's a CMRI monitor, there's a serial monitor, there's my root, and here's my turntable. And I'll go all the way around to number 8 first and then work way back to show you how it works. So there you go, 8 position, we've selected 8 up here, and there's the output from JMRI. 7 position. So the best thing about this way compared to the lights is as I click on the sensor, the other sensor light goes out, so you know what position you're in. 6, 5, position 4, 3, 2 and 1. So it works really well. I've never had any problems of getting it into the positions that I need. So that's probably as far as I'm going to go with this code, because I've got to get the turnout working well. I'm going to show you a problem with that as well. With the code, if you want the train coming on this point here, and you want it to do a 4 degrees to come out this point, you'll probably have to add more sensors closer so that you can operate them sensors to get the train to go 180 degrees to come off again. That's the way I was going to do it. There's probably different ways of doing it. You can obviously post down the bottom or go on my website and put some posts on there, because there is going to be links on the website to this. My previous part with the lights is on there already, and the problem that I'm having, hopefully I'll get some comments back from the JMRI team, see whether there's a better way of doing this. So for now, I'll show you my next problem. I'll just grab the camera from down here. Right, so my next problem is that when the JMRI, when the turntable actually comes around to line up, so I'll just bring it onto this one here. This one's already fixed in position, and it lines up here. The actual alignment's not great because there's a bit of play. You can see with my fingers, it was lining up perfect, like that, and then I noticed that sometimes it'll be out. So the stepper motor has quite a bit of play on it. And that play probably comes from the centre, this centre nut as well that I've got here. There's probably a bit in there as well. So that's not great because you're never going to get a perfect alignment every time. So I'm looking at possibly either using a miniature solenoid on here that will shoot into a position here to lock this into position, which would be a nice way of doing it if I could get one to work, or maybe a servo here where the servo arm comes around and locks this in position. So there's two options there I'm looking at. And the other thing I need to do is obviously make a better turntable because it looks a bit rubbish. It's scraping on here quite bad, so I'm going to have to rattle all this out to the point. I'll just turn it off. If I turn the power off, it moves down. You can hear the scraping, and a lot of the time it will get stuck in position. It just go make a load of noises. So there's a lot of mechanical and building work to do. My main thing was to get the code working. So I want to get the code working so that it lines up in the right position and locks into position, because it's not worth spending ages building a model up when the actual turnout doesn't work properly. So that's for now. I'll try and get this on my website as soon as I can. Hope you enjoyed it. Please subscribe if you do, and anyone's got any comments on better ways of doing this or wants to add to my progress, feel free to comment on here or go on my website and you can comment there as well.